According to the National Electrical Code, all electrical systems must be effectively grounded. In the case of variable speed drives, the NEC requires a dedicated equipment grounding conductor connected to the chassis of the drive and extended to the service panel or grounding electrode system. Since the building was constructed in the 1970s, it is possible that it does not have a modern grounding system. You need to determine the type of grounding system you have to ensure proper grounding for the AC units. 1. Inspect the panel. Look for a grounding busbar connected to the neutral bar in the panel. If present, it indicates a UFA grounding system, which is not acceptable for grounding variable speed drives. 2. Check conduit. If there is no grounding busbar, determine if the conduit serves as the utility ground. This can be done by measuring the resistance between the conduit and the earth. A reading of 25 ohms or less indicates adequate grounding. 3. Building steel. If the conduit is not grounded, consider using building steel as the grounding electrode. However, it must be electrically continuous and properly bonded to the electrical system. 4. Back to switchgear. If neither building steel nor the conduit is suitable for grounding, the best option is to run a dedicated equipment grounding conductor back to the switchgear or grounding electrode system. Based on the information provided, the recommended solution is to run a dedicated equipment grounding conductor back to the switchgear or grounding electrode system. This ensures a reliable and code-compliant grounding path for the variable speed drives. Verify the electrical rating of the steel if using it as the grounding electrode. Ensure all connections are tight and properly secured. Consult with a qualified electrician for further guidance and assistance. The purpose of grounding is to provide a low impedance path for fault current to return to the source, which allows overcurrent protection devices like circuit breakers or fuses to quickly trip and clear the fault. In older buildings, the grounding methods may not meet current code requirements, so it's essential to evaluate the existing system and upgrade it as needed to ensure safety and proper operation of new equipment like variable speed drives. A dedicated equipment grounding conductor provides a more reliable grounding path compared to relying solely on conduits or building steel, especially for sensitive electronic equipment like variable speed drives. It helps to minimize electrical noise and prevent equipment damage or malfunction. The National Electrical Code Article 250 covers grounding and bonding requirements for electrical systems. It specifies the size and type of grounding conductors, the methods for connecting to grounding electrodes, and the bonding requirements for metal enclosures and equipment. In addition to the equipment grounding conductor, it is important to ensure that all metal enclosures and equipment are properly bonded together to create an electrically continuous path to ground. This helps to prevent voltage differences between different parts of the electrical system, which can be a shock hazard. When using building steel as a grounding electrode, it is important to verify that it is electrically continuous and properly bonded to the electrical system. This may require additional bonding jumpers or connections to ensure that the steel structure provides a reliable grounding path. It is also important to consider the size and type of the grounding electrode. The NEC specifies minimum requirements for grounding electrode size based on the size of the service entrance conductors. The grounding electrode must be made of a material that is resistant to corrosion, such as copper or galvanized steel. When running a dedicated equipment grounding conductor back to the switchgear or grounding electrode system, it is important to size the conductor according to the NEC requirements. The size of the grounding conductor depends on the size of the circuit conductors. It is also important to ensure that the grounding conductor is properly connected to the grounding electrode system. This may require using a grounding electrode clamp or connector that is listed for the purpose. The grounding electrode system typically consists of one or more grounding electrodes that are connected together to form a low impedance path to ground. Common types of grounding electrodes include ground rods, ground plates, and concrete encased electrodes. The grounding electrode system must be located as close as practical to the service entrance. This helps to minimize the length of the grounding conductors and reduce impedance. In addition to the grounding electrode system, it is also important to ensure that the neutral conductor is properly grounded at the service entrance. This is typically done by connecting the neutral conductor to the grounding electrode system. The neutral to ground bond helps to stabilize the voltage and prevent voltage differences between the neutral and ground conductors. When working with electrical systems, it is important to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It is also important to de-energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Before working on any electrical equipment, it is important to verify that the circuit is de-energized using a voltage tester. This will help to prevent electrical shock. If you are not qualified to work on electrical systems, it is important to consult with a qualified electrician. An electrician can help you to safely and properly install and maintain your electrical system. Understanding the different types of grounding systems is also very important. The NEC recognizes several types of grounding systems, including grounded systems, and impedance-grounded systems. Grounded systems are the most common type of grounding system. In a grounded system, the neutral conductor is connected to ground at the service entrance. This provides a lower impedance path for fault current to return to the source. Grounded systems are not as common as grounded systems. In an ungrounded system, the neutral conductor is not connected to ground. This type of system is typically used in industrial applications where it is important to maintain power in the event of a ground fault. Impedance-grounded systems are a type of grounded system that uses an impedance, such as a resistor, to limit the amount of fault current that can flow in the event of a ground fault. This type of system is typically used in applications where it is important to protect sensitive equipment from damage due to ground faults. When installing variable speed drives, it is important to follow the manufacturer's instructions for grounding. The manufacturer's instructions will typically specify the type and size of the grounding conductor that is required. It is also important to ensure that the variable speed drive is properly bonded to the electrical system. This will help to prevent voltage differences between the variable speed drive and other parts of the electrical system. In addition to the NEC and the manufacturer's instructions, it is also important to follow any local electrical codes. Local electrical codes may have additional requirements for grounding electrical systems. By following all applicable codes and regulations, you can ensure that your electrical system is safe and properly grounded. Remember that proper grounding is essential for the safety of people and equipment. It is important to take the time to properly ground your electrical system. Improper grounding can lead to electrical shock, equipment damage, and fires. When in doubt, consult with a qualified electrician. They can help you to ensure that your electrical system is properly grounded and meets all applicable codes and regulations. Furthermore, consider the environment where the variable speed drives are installed. If the environment is harsh or corrosive, it may be necessary to use special grounding methods or materials. For example, in a corrosive environment, it may be necessary to use copper grounding conductors and connectors. It is also important to protect the grounding conductors from physical damage. This can be done by routing the grounding conductors and conduit or by using other protective measures. Regular inspections of the grounding system are also important. This will help to identify any problems with the grounding system before they can cause a safety hazard. During inspections, check the grounding conductors for damage or corrosion. Also, check the grounding connections to make sure they are tight and secure. If any problems are found, they should be corrected immediately. In addition to visual inspections, it may be necessary to perform electrical tests on the grounding system. These tests can help to verify that the grounding system is functioning properly. One common test is to measure the resistance of the grounding electrode system. This test can be performed using a ground resistance tester. The resistance of the grounding electrode system should be low, typically less than 25 ohms. Another common test is to measure the voltage between the neutral and ground conductors. This voltage should be low, typically less than 1 volt. If the voltage between the neutral and ground conductors is high, it may indicate a problem with the grounding system. Remember that grounding is not the same as bonding. Grounding provides a path for fault current to return to the source, while bonding connects metal parts of the electrical system together to create an electrically continuous path. Both grounding and bonding are important for electrical safety. In some cases, it may be necessary to install a separate grounding electrode system for the variable speed drives. This may be necessary if the existing grounding electrode system is not adequate or if the variable speed drives are located in a different building than the service entrance. When installing a separate grounding electrode system, it is important to follow the NEC requirements for grounding electrode systems. This includes the requirements for the type and size of the grounding electrodes, as well as the requirements for connecting the grounding electrodes together. It is also important to ensure that the separate grounding electrode system is properly bonded to the existing electrical system. This will help to prevent voltage differences between the two systems. Finally, remember that electrical codes and regulations are constantly changing. It is important to stay up to date on the latest codes and regulations to ensure that your electrical system is safe and compliant. You can stay up to date on the latest codes and regulations by subscribing to industry publications, attending training courses, and consulting with a qualified electrician. Grounding, bonding, surge protection, and proper overcurrent protection are vital elements for a safe and reliable electrical system, especially when integrating modern equipment like variable speed drives into older buildings. Ensuring the grounding system is correctly implemented and maintained prevents electrical hazards and equipment damage. When dealing with older electrical systems, it's vital to meticulously assess the existing infrastructure and make necessary upgrades to meet current safety standards and accommodate new technologies. Variable speed drives, while offering efficiency and control, introduce unique grounding requirements that must be addressed to ensure their safe and reliable operation.